Hey, welcome YouTube. All right, so this is supposed to be part 4 of the grade 6 show your work hardest math problems. However, the video that I recorded for part 4 has a problem. So what I need to do is look at it and figure out how to chop it up into pieces. At the same time, I found that I think I want to split parts out of it anyway. I should have done it as multiple streams in the first place. So, I'm probably going to have to skip over the beginning because that seems to be the broken part, and the second half seems okay. And since there's some goodies stuck in the middle of that, that's the way we're going to go. So originally this is going to be one giant part 4, and I might actually split it up into 5 parts. What I may have to do is re-record the beginning of it. The first, I don't know how many problems, maybe 3. All right, so what I'm going to do is I'm going to black the screen, and probably put this little speech in the front of each part. In the meantime, I'm going to try to get pumping out the parts I can get out. Okay, 42 has an interesting illustration, which normally does not appear on these kind of exams that I'm pulling these from. But it's a good question. It actually comes up in enough areas, including in the real world, so it's worth knowing how to do. Give me 1 second here. I scrolled too fast and I ended up who knows where. This test is not syncing with my brain for some reason. Okay, so we have an illustration. We have a 6 by 6. It looks like a square, and it looks like there's an inner square that's not shaded. That's 3 inches by 3 inches, perhaps, and another one that's 2 inches by 2 inches. So these all look like squares, but I'm not sure. Normally, since this is shaded here, they're going to ask us for a shaded area question. Again, I don't know where they're going. So let's see. The diagram below shows a larger square with 2 smaller squares. All right, so it definitely is. All right, so that means this is 6 inches, and that this here, this length right here, that's 2 inches, and that this length here, that's 3 inches, okay? Write an expression. So we talked about that before. An expression is not an equation. An equation has an equal sign involving exponents to represent the shaded area in square inches of the diagram. So what we're basically doing is this is called composite shapes. They want us, what they're asking us to do conceptually is to take that larger square and remove from it the 3 by 3 one and remove from it the 2 by 2 one. So what we're trying to do is map the words and the visual into an expression. Okay, so it's basically the large square, right, minus the middle square minus the small square. Okay, but that has to work in a specific way. All right, so what we're going to have is 6 squared, right? Because the area of the outside, the area of the large square minus the area of the middle square minus the area of the small square. So 6 squared, 6 times 6 is the larger one. We're going to subtract from that, okay, the middle square, which is 3 squared, and then subtract from that the smaller square, which is 2 squared. Okay, so that's one way to do it. Okay, and then it says, then use that expression to calculate the shaded area. So we get 36 is the whole space, minus 9, which is this, right? Minus 4. All right? So 36 minus 9 is 25, right? Minus 4 is equal to 21. All right? Did I do that right? No, I didn't. This is 27. Minus 4 is 23. Okay, always back up. Make sure you're doing it right. An equivalent expression would have been saying, let me take the area of the large square and subtract from that the area of the unshaded squares. Okay? And we could have written that as parenthesizing that if we wanted to. So what we could have had was 6 squared minus, and the area of the inner squares would be 3 squared plus 2 squared. Okay, in this case, we're going to follow PEMDAS then. So we can get 36 minus 9 plus 4, or 36 minus 13. All right, that gives 23 again, right? So those are both valid ways to do that. There's really not much other variance to this. So, and since we want to always check, this was in inches, this was in inches, this was in inches, and nothing else said anything. So this is going to be in inches squared is the answer. So if you had square inches at the end here, yes, we do. So we always use this to kind of confirm we're in the ballpark. First of all, we want to know that our answer's in the right units, like inches, first of all, the unit of measurement, and then which dimension is in. Like a flat thing, a square thing, a cube thing, whatever. All right? And let me just come back here to make sure we answered the full question, see if there's anything left, right? This process, if you guys see me just go at the problem, at the problem, at the problem, it's always the process. There's no, you practiced a few of these at school or whatever, you should be in that ritual. It should be a habit. It's the same mathematical process each time. The question's different, the solution's different, but starting by figuring out what you're being asked, underlining important stuff, and just breaking down the problem. Don't leave the problem till you check the units. Don't leave the problem till you check the answer. Don't leave the problem until you feed it back into the question, right? You know, we know if the whole thing was 36, or we can even say 40, right? These parts out of here. So if you ended up with an answer bigger than 40, you know you're in outer space, right? If you end up with an answer very close to 36 or 40, then you know that you didn't take enough away. Because you guys can see here, we ended up with 23, okay, which is about a third off of it. You know, if you took the original thing, you know, put the 3 by 3 over here, right? Remember, this was a 6 by 6. So if we put the 3 by 3 here, we've already taken a quarter of the shape away. All right? We've already taken the 3 by 3. We're taking 9 away. And then we're going to take a 2 by 2 away. Okay? So we're the part that's left here is not a lot when we shift it over into the corner, if you will. Right? So there's ways to kind of figure this out and double check, is my answer even ballpark? Right? And you don't want it to be ballpark. You want the answer, but in terms of estimating, you should also approach your problems with estimation aspects behind it or whatever too as well. All right? So that's the deal, peeps. That's the deal. Okay, so we want to follow PEMDAS. It said involving exponents. Technically there was other ways to do this because we could have said 6 times 6. Right? Instead of 6 squared, we could have said 6 to the 1 times 6 to the 1. That's getting too esoteric. You guys know they're not looking for something like that as the answer choice, right? So anyway, this was unique in the sense that it used these composite shapes. Composite shapes is when we take the pieces out, like we're just like the 3 by 3 and the 2 by 2 from the greater figure. Because there's 3 squares there. There's not just one. It's not a square with 2 holes. It's 3 squares. Depends how you look at it, right? We could argue those are windows or something. In any event, that's what's going on there. If you needed to figure out how to paint a room or something, that's part of what you're doing. You have a wall, and you're going to pull the window spaces off of it because you're not going to paint the windows. At least I'm not going to. Maybe you guys will. All right? And that's what we're doing there. So again, multiplication, PEMDAS, geometry, knowing how squares work, the areas of squares. So this problem was really all over the place. And I'm glad they included something like this into this particular exam I pulled it from. But generally speaking, you guys don't often see something like this a lot anyway. And it should really come up more often. It's normally on kind of more involved standardized exams and so on. It should be on your regular classwork and so on too. And check out GregsTutoringNYC at gmail.com/hardest-math. You can email me at the bottom, GregsTutoringNYC at gmail.com. And I'm going to give you guys double piece again. Where's the camera? Right there. Yeah. All right, guys, take it easy.